Hello everybody, Mr. Chan here. We're going to be doing a lesson for Algebra 2, 1-5, solving equations and inequalities by graphing. Please turn your note takers to page 17. If you're following along in your textbook, it's on page 40. A homeowner has 32 feet of fencing for a rectangular chicken run. You can see from the picture, we have some information right there and label of perimeter equals 32 feet. This particular section, we're actually going to solve equations by graphing. You may utilize a graphing calculator like our Casio, or you can download and utilize the free one from Desmos.com. That's spelled D-E-S-M-O-S. All right. Make a table of values for the length, width, and area of different rectangles with perimeter 32 feet. Then write a function for the area in terms of width of rectangles with this perimeter. Now before I do that, let's write down some things we do know from geometry. Let's write down our perimeter formula of a rectangle. Drawing a rectangle, we all know that a rectangle has length for one side and width for the other side, and they are at right angles to each other in order for this to be an actual rectangle. And for the perimeter, it's a distance around that shape. L plus W plus L plus W simply combines together to be 2 times the length plus 2 times the width. Ultimately, we need to come up with a formula for the area of a rectangle. So let's write that down. Area of a rectangle is length times width. Now, if you look at this formula here, we see that there are 2 variables, L and W. They want our answer, our function, in terms of width. The other variable, L, needs to be replaced with another expression. Well, we're going to have to move to the perimeter formula, and you notice L is over here, can be isolated, and take what it equals to and substitute it into the area formula. All right, using the perimeter formula, let's replace P with 32. That's our restriction there. That's good. We can make the coefficients 32, 2, and 2 a little smaller. Let's divide by 2. L is almost by itself. That is my goal. I need to isolate L and take what it equals to and put it into the area formula. Well, we have L plus W. To isolate L, I'm going to subtract W to both sides. And when I do that, I'll be left with a 16 minus W equals L. Take what that equals to, 16 minus W, and let's do a little substitution. Whoa, right into that variable in the other equation. Let's replace it. L times W. L is no longer L, it is now 16 minus W. When you rewrite this, let's write it as a function. Function notation you might have seen or remember from Algebra 1. This formula is in terms of W. When you guys learn function notation in Algebra 1, you might have heard like function notation like f of x. And that's how you said that. It's a function in terms of x. Here, we're creating a function called area in terms of W. So what I'm going to write down is function notation A of W equals to 16 minus W times W. Be careful. This is not A times W. This is A of W. That is function notation. You can clean this up, of course, by distributing the W. And this equals to 16W minus W squared. All right. Ultimately, we need to make a table of values. Let's do that. We have some scenarios involving width and length. And ultimately, that will produce values for area and perimeter. They've already given us a coordinate plane off to the left here. Let's go and make a couple of axes here. Now keep in mind, we're playing with 16 in my formula over here. That represents the length and the width of the chicken run. So when I combine L and W in the table, it should add up to 16. We can start small. It doesn't matter. Let's do that. If, let's say, the width is 4, just randomly pick that out of the air, my length has to be 12 because 4 plus 12 is 16. Continuing with the table, that means the area is 4 times 12 or 48. We're just looking for a pattern. Now keep in mind, this coordinate plane is based off of the width and the area based off the width, like that. So label those. I have a feeling, since we're picking lengths and widths between 0 and 16, let's go ahead and position that accordingly along the W axis or the horizontal axis. We'll go by 2s. I believe that will work. Aha, I'm correct. So, using the table to finish my perimeter and area, remember, perimeter is fixed. It will always be 32. My formula was reduced to 16 equals L plus W. So another possible, oh, let's plot this. Let's see, area is 48. We need to figure out something very careful here. The number 16, if I were to cut that in half, I would get 8, wouldn't I? I'm gonna give myself a little space there. Half of 16 is 8. I believe 8 would mean something important here. The area of 8 times 8 is 64. So what I'm trying to do is create a vertical axis where it will accommodate all these numbers. 64 is kind of big, so I'm going to go ahead and put in some tick marks and go by 10s. Let's see if that works. To accommodate 64. This is not an easy part to figure out what your axes should be. Aha, that works. So let's plot those 2 points. We're plotting W, comma, A of W, or the area. 4, comma, 48 is first. So it's about right there. The other point that I threw in was 8, comma, 64. Let's plot that one. Now, I don't know about you. Right now, it looks like if I were to connect those dots, it would look like a line. Let's go ahead and plot some other possible pairs. Let's pick maybe 6 and 10. 6 times 10 is 60. Let's plot that one. Interesting. It's no longer on a line. Maybe 7 as a possible width, which means 9 has to be the length. 9 times 7 is 63. Oh, okay. So that's kind of interesting there. What happens if I switch it to 9 and 7? Well, 9 and 7 are 63 as again. These match, don't they? So it looks like it's going to drop back down. In fact, it mirrors the numbers that are already in the table already, 10 and 6. And 12 and 4 will give you the same areas. And when you plot it over here, you'll get a familiar shape that you learned about in Algebra 1 called a parabola. All right, I'm going to go ahead and connect the dots. Where does it hit, you think? Where will it go there? Let's take a look here. If I plug in 0, what would my 0 be? The length would have to be 16. I'm just curious how this parabola extends left and right. 0 times 16, it is 0. 0 times 16 is 0. You can't have the area of a rectangle that has a dimension that's 0, so the area is 0. So it does go down all the way to here on this side, and I'm going to guess it's going to go to 0 over here on the other side as well. In fact, that's where the parabola crosses the x-axis. Whoa! Very cool. Not only do we have a function in terms of w, we now have a table, and we have a graph that represents our problem. All right, explain what happens where the graph intersects the x-axis. Oh, I kind of mentioned that. When it intersects the x-axis, these 2 points right there, the area equals 0 because one of the sides equals 0. All right. Let's look at the question at the bottom there. For what widths will the area of the chicken run be best for at least 55 feet? Okay, that's kind of interesting. They're changing the problem on us. Be at least 55 square feet. Take the function. Throw it into an inequality. At least means 55 or greater. It's kind of one of those backwards thinking expressions. At least means greater than or equal to. So what you can do is simplify this, put in a graphing calculator, and solve it. We can do that in class. Next page. All right. Now this whole section is using a different approach to solving equations. Normally you would undo operations with like the first one, 5x minus 12 equals 3, and that's fine and dandy. But because of technology and graphing calculators, we can now see both sides of the equation and see where they cross. And why do we do that? Because of the equal sign. We're going to treat one side of the equation as one equation, and we're going to treat the other side as another equation. On your graphing calculator, those will be 2 separate y functions. What I've done ahead of time is I have put these equations into Desmos. So let's go ahead and do that. I'm going to switch over to that app on the internet called Desmos. Oh look, ta-da! On the left there, I've already typed them in. Y equals 5x minus 12. Let's turn that on. You can see that on the green line there. And y equals 3 on the other side. And look, lo and behold, they cross in one spot. And if I hover my mouse over there, it covers at 3, 3. Perfect. Remember that. Whoops. All right, switching back to the note taker, let's go and plot what we saw on Desmos onto this coordinate plane. It's mostly in the first quadrant, so I'll just go ahead and eyeball it and put in some vertical and horizontal axis. The left side is technically 5x minus 12. So remember, we use either a graphing calculator or Desmos. And that helps us in our graph. And remember, the equal sign separates the two sides into y1 and y2. I'm going to go and graph the y equals 3 first. And the other one is 5x minus 12. It's kind of hard to do because the axes don't necessarily, but I do know that it does cross through 3, 3 using my graphing tool to represent that. Yay, there's my solution. Use a graph to solve the equation. Now 3, 3 is a coordinate pair, x, y. I am only interested in the x value. In this case, it's the number 3. X equals 3 is the solution. So those were a couple of lines. The next one involves an absolute value function. On the left there. And on this side, we have a linear function. Again, I'm going to use a graphing calculator, or in this case, Desmos, to separate the two because of the equal sign. This is a great technique. This didn't exist when I was a student because we didn't have graphing calculators in high school. All right, we know that an absolute value is a V-shaped graph. And something interesting, this particular V-shaped graph, there's a negative sign in front of it. So we know the V is probably upside down. Let's go and switch over to Desmos on my website. There we go. Let's go and turn off those two graphs from earlier for example 1. And let's turn on example 1b. Oh, there they are. Nice. Isn't technology great? Notice that if I hover, my intersection right there is 0, -2. And down here, it's 8, -6. Wonderful. Let's switch back to our notes and draw that in. This time it looks like we're in the fourth quadrant. Let's go ahead and draw our axes to reflect that. Great. The left side is a absolute value function. It did start at 2, 0, and it went this way, whoa, to the left of the vertex, and then to the right of the vertex. Algebra 2 is very different now. We're utilizing technology to graph things that we've already learned or so should have learned. The other half is -1/2 x minus 2. Let's graph that. Remember, it crossed that 0, -2 is one of the solutions, and the other one was 8, -6. Should probably extend that further. Whoa. So I can make that connection at 8, -6. All right. Be careful when you write the answer down. We have 0, -2, and 8, -6 according to Desmos. We don't want the coordinates. We want the x value only. 0 and 8 are my solutions. I didn't check last problem there. You can always plug the numbers in. Plug in the number 3 for the first problem. Oh, look, 5 times 3 is 15. 15 minus 12 is 3. It works. Same thing over here. Plug in 0. 0 minus 2 is negative 2. Absolute value of negative 2 is 2. Throw in a negative on the other side, you have negative 2. On the other side, plug in 0. The first part disappears. Minus 2 will give me negative 2 as well. So that works too. So a lot of ways to check your answer. Let's move on to example 2. Any questions? All right. More or less of the same thing, but this time we're dealing with inequalities, not equalities. We're still going to use the same approach of using decimals to graph the left side as well as the right side. A lot of the time is taken away and with using technology, so we don't have to spend all that time to try to figure out how to graph x squared plus 6x plus 5. All right, let's go back to decimals. Turn off the 2 graphs from example 1b, and let's move on to example 2a. We've got the left side of the equation, inequality in this case, happens to be greater than or equal to, and the other one is 0. May have been subtle. Did you see that? It's a green line, and actually it hovers above the x-axis. So this is kind of interesting. It's a parabola that opens up, and we have a horizontal line, y equals 0, that intersects it here at negative 5, 0, and over here at negative 1, 0. Let me see if they can click that going. There we go. Negative 5, 0, and negative 1, 0 are my 2 intersects. Let's go ahead and copy that into our note taker. All right. Looks like we're in the second and third quadrant. Let's give ourselves a little space here. And I noticed that in decimals, my vertex was at negative 3, negative 4. And the intersection of the green line was at negative 5, 0 and negative 1, 0. Let's draw on our parabola. There we go. Great. Again, same process. Not exactly like the last 2 examples, though. The key here is where is the parabola greater than the horizontal line at y equals 0? Excuse me. We are referring to the y values. Where are the y values greater than the other one? Let me grab a highlighter. As I move from left to right, the yellow graph that is above the green graph happens to be here and here. To describe that, I need to use set notation and internotation. This relies on the domain to describe that. To describe where the portion of the graphs of the parabola is above the horizontal line. So let's start with the left piece. That left piece relative to x is where it's going to the left, literally. So that's going to be less than or equal to. Keep in mind, It's greater than or equal to 0, so it includes 0 as well. So basically positive or 0 is one way of looking at it. The other half of the parabola, we can write this down as being positive or 0. It's to the right of -1. To the right of -1, including -1, it's going to be x is greater than or equal to -1. That's using set notation. You can write it using interval notation like this. All the way to the far left is -infinity. At -5, it's a bracket. Or using the U symbol, going from -1 all the way to positive infinity to the right. Those are those numbers right there along the domain. All right? That was not easy. If you got through that, great. If you have questions, please ask me. Let's move on to the next one. We've got the left side is a line, and the right side is another line. But this time, we want to see where it's greater than only. So this is only positive, not equal to 0. Again, we focus on the y value. Let's switch over to Desmos. Here we go. Turn off those two that we just had a moment ago and turn on the two equations. Ah, there we go. So for the left side, I notice it has a slope of 1 and has a y-intercept of 3. Great, that's easy to do. And the second graph, or on the right side of the inequality, has a slope of -3. It's written backwards. mx plus b is written backwards. And it has a y-intercept of 7. And where they cross looks like 1, 4. Let's go and switch back to our note taker. Here we go. And this is mainly in the first quadrant. Let's go and represent that on this corner plane. Great. The left side line, let's draw that first, has a y-intercept of 3, and it's going up 1 over 1. You know, we've been doing a lot of graphing lately. If you have trouble with some of the graphs we're doing, please let me know. It's not a big deal. It's been a while since you've done Algebra 1. All right, there's the left side. And the right side is -3x plus 7, technically, if you think about it that way. Putting in mx plus b form. Its y-intercept is 7, has a slope of -3, so let's find that right there. Bam, there it is. Did we need decimals for this necessarily? No. It's kind of nice to have. All right, the key here is, where is the orange line greater than the green line going from left to right? Well, using a little highlighter, I can see where they intersect is where the orange line will be greater than it. The x value of that intersection at 1, 4 is 4. You all see that? The x value is 1. That's what will drive the domain answer. Here we go. All values of x such that x is now, it's going to the right of 1 now, but not including 1. We're not looking for or equal to 0. We're only looking for positive. So this is greater than 1. That's all you need for your answer. You can, let's go ahead and put it in interval notation form. 1 is first, it's parentheses because you're not including it, all the way to infinity to the right. And there it is. Great job. Okay, the last two on the next page, I'm not going to do the last page, but everyone, let's go and switch to the next page. A lot of graphing, but they're basically the same. Using graphic technology or decimals really helps us a whole lot. Now, they want us to use a spreadsheet. I'm going to create 3 columns here. Pick some x values, and that will help determine the left side, x squared minus 4x plus 1. We'll call that y1. And the right side, x minus 2. Happens to be a single line. y1 was a parabola, and y2 is a line. When we graph problems that don't come out nicely, sometimes we explore what would happen with decimals near the whole numbers. If I switch over to Desmos, you will see turn those off. Aha! That the parabola as well as the line don't meet nicely at all. Notice the first intersection is at 0.697 and negative 1.303. I do need to warn you, I'm kind of jumping ahead a little bit. They only want us to look at the second solution where the parabola crosses the line. The second solution they're telling you is between 4 and 5. That's kind of interesting. So this is like being a detective. It's kind of weird though, because we have graphing technology that'll give us the answer right away. But back when I was a student, we would like try to plug numbers in. We might plug in 4, get an answer. Is it close to the solution? Maybe pick 5. Maybe that's too big. Then we start picking numbers in between 4 and 5. It was a lot of work, definitely. 4.1, 4.2, you get the idea. And what we're doing is we're trying to equal, that's the key here. We're trying to equal both sides of the equation. We're trying to make the 2 columns get there. So my point is this. I'm going to save you a little grief here. The numbers that do come out when you plug in 4.1, for the first half, you get 1.84. But on the other side, we get 2.2. Okay, interesting. When we plug in 4.4, that might be a guess that you're doing. We got 2.16. And the other side was 2.4. Wow. Very close. All right. I think I misread that number. This is 2.76. There we go. Much better. So Y1 was lower with 4.1. Then it jumped higher with 2.76 versus Y2. That's why it's kind of like a guessing game, kind of like the game on The Price is Right, when Drew Carey asked, "Okay, what name the price of the car or the furniture?" And he'll say higher, lower. We're kind of doing the same thing here, but ultimately the best answer is 4.3. We're going to make sure that I got this right. I said 4.2 earlier. 4.3 got you really, really close to them being equal. I haven't even drawn it. From Desmos earlier, it looked something like this. So nothing's perfect here, folks. We're just approximating the answer right now. This is interesting. Where they equal is what that pair of numbers represents right there. We can use a graphing calculator and solve. In fact, our Casios are really amazing. They'll actually give you the actual answer. And I'm going to give you that right now using the technology. The intersection, round to the nearest thousandth, is 4.303, comma, 2.303 for the y value. This is the number where they're equal along the x-axis. Okay, that's where it is. Let me show you that under Desmos. And hover my mouse over there. Oh, there it is, 4.0303 and 2.303. All right. Let's go ahead and jump to the last problem of the day. Any questions? This is the solution. This is where it equals. This is an approximate answer. Round to the nearest thousands, okay? All right. Use the graphing technology to solve equations. It's pretty much the same as the last problem. I'm going to go ahead and jump to decimals one last time. I realize that I didn't input those equations yet, so I'm going to have to do that right now. The left side is y equals to x squared. It's kind of cool. I'm using a keyboard to type it in. Plus 2x minus 1. Great. And the other side is absolute value of x plus 2 plus 2. I hope I'm typing this in right. Yay, there it is. All right. If I hover my mouse over here, I'll get a funny answer, negative 3.303, and I don't really care about the y value. Over here, 1.791. That's it, I know. You just want to see where they're equal. Let's go and transfer that information to our note taker. Here we go. They didn't give us any graph paper, but we're just going to go ahead and mimic the whole thing from decimals. The left side is a parabola. The right side is an absolute value function. Wow. It's amazing nowadays. You can get a lot of math done by using technology. We trust you guys. As long as you know what's going on, we don't mind you guys using the technology to assist in your learning math. So I'm going to eyeball this. Please be patient. Eyeballing this from decimals and my parabola. Oops. Let's do this. 3.3 right there, and 1.79. It's about right there. And kind of approximate a parabola that was shown on decimals. Not, oh, so close. Let's try that again, Mr. Chen. Wow. Hand-eye coordination. Bam, close enough. And those intersections, we'll label those. Here and here, they were these funny decimals. All right, and we only need the x values, of course. And there they are. Oh, they want us to round to the nearest tenth. Much better. X equals to negative 3.3. And 1.8. And there it is. I think that's plenty of examples for the day. Let me know if you have any questions. I'm going to go ahead and end this recording. Have a good day, everybody. Bye-bye.